All right, welcome back to another episode of Science with Surbeck. In today's episode, what we're going to be focusing on is Newton's second law, and specifically using Newton's second law formula. So what I want you to be able to do by the end of this lesson is to be able to efficiently and effectively solve for any variable in the Newton's second law formula. So let's start out with this. Newton's second law, in terms of mathematical operations, says this: our force equals our mass times our A for acceleration. Okay? Now, we went over in notes what specifically these units are for each of these things. Remember, force is in newtons, mass is in kilograms, and then A for acceleration is in meters per second squared. So what I'm going to do here is I am going to show you how to solve for each type of variable. And so what I'm going to show you in this video is I'm going to do problems number 1, 2, and then we're going to go all the way down to number 5, and I'm going to show you how to do each of those. What that will allow us to do is that will allow us to see how to solve for each of these particular variables. So problem number 1, it says a 214 kilogram boat is sinking in the ocean. The force of gravity that draws the boat down is partially offset by the buoyant force of water. So the net unbalanced force on the boat is negative 1,310 newtons. We want to know what is the acceleration of the boat. So just like in any other math problem, what we need to do is we need to list out our variables, find out what we know and don't know, and then plug this back into our equation and solve mathematically. So our force will always be in newtons, and if we read the problem over again, we see the force in newtons is listed at negative 1,310 newton. And that is in the correct unit, so we don't have to do any conversions. The mass should be the item listed in kilograms, and it said it was a 214 kilogram boat, so we just write 214 kilograms. And then the acceleration. There is, in problem number 1, nothing that says meters per second squared. So this becomes our question mark. So what we end up doing is this. We plug our numbers back in, and we have negative 1,310 equal 214 kilograms times our unknown A. Now, A acceleration is attached to 214 via multiplication. So the way in which we get rid of this is we divide by that 214 kilograms. And what we do to one side, we have to do to the others. So to solve this, and I should have put newtons here, to solve this, what we have to do is in our calculators, what we have to do is we have to put negative 1,310 divided by 214, and we press enter. So in the calculator, we get negative 6.12, and there's some stuff after that, but for this answer, I only want 2 decimals. So our answer would be negative 6.12. And so that's what A would equal. So A would equal negative 6.12. And now think back to what the unit is for acceleration. And that unit for acceleration is meters per second squared. So this right here, negative 6.12 meters per second squared, becomes our answer. All right, so that was how we solve for acceleration. This next problem, what we're going to do here is solve another variable. So it says the tallest man-made structure at present is the Warsaw radio mast in Warsaw, Poland. This radio mast rises 646 meters above the ground, which is nearly 200 more meters than the Sears Tower in Chicago. Suppose a worker at the top of the Warsaw radio mast accidentally knocks a tool off the tower. If the force acting on the tool is 3.6 newtons and its acceleration is 9.8 meters per second squared, we want to know what is the tool's mass. So again, what we do here, it's a Newton's second law problem, so we're going to use that same formula. We have force, mass, and acceleration. And we just list this out. We look for what we know and don't know. Force is always going to be measured in newtons. So if we read the problem, we find here the amount of newtons here is 3.6 newtons. Now, the mass of the tool, if we read carefully, it says, what is the tool's mass? So we don't know. This becomes our question mark. And then the A for acceleration. Well, acceleration is always in meters per second squared. So we have this listed at 9.8 meters per second squared. Okay, so we know two of the three things. We can now plug this back into our equation. So we have 3.6 newtons equal our m for mass. We don't know what it is. Times our acceleration, which is 9.8 meters per second. Okay, this m for mass is attached to 9.8 via multiplication. So to get rid of this, what we have to do is we have to divide each side by 9.8 meters per second squared. And so to find the numerical value for this particular problem, what we're going to do is we are going to, in our calculator, we're going to punch in 3.6 and we are going to divide it by 9.8. So we divide this by 9.8 and we get an answer. And we only want two decimals here in this case. We get an answer of 0.367 and that would round to 0.37. So our m for mass would be 0.37 and then our unit. Remember, our unit for mass is kilogram. So kg. All right, so we have solved two of the three variables, or I've shown you how to solve two of the three variables. We're going to skip on down to number 5 because that allows us to solve for another variable. So it says in drag racing, and acceleration is more important than speed, and therefore drag racers are designed to provide high accelerations. Suppose a drag racer has a mass of 1,250 kilograms and accelerates at a constant rate of 16.5 meters per second squared. We want to know how large is that unbalanced force acting on the racer. So again, we're using that same formula that we've used this entire time. So we have our force equals mass times acceleration. So all I'm going to do first is I'm just going to list out each of those variables. So again, force. Force is always going to be shown in newtons. So we can read through this particular problem and we can not locate anything that has newtons. Well, that's because, hey, we want to know ultimately what is that force of that automobile that's drag racing. Then the mass. If you read the problem closely here, it says the mass is 1,250 kilograms. So we have 1,250 kilograms. Now, the acceleration. It said the drag racer is accelerating at 16.5 meters per second squared. So that becomes our acceleration. Now we know two of the three things. So what we do here is we have our F for force equal to our mass, which is 1,250 kilograms times our acceleration, which our acceleration is 16.5 meters per second squared. So in our calculators, what we are going to do is we're going to type in 1,250. So we have 1,250 times, we're going to multiply that by 16.5. And we're going to press enter, and we are going to read this to 3 total digits. So we have 20,625. We're actually going to round that down to 20,600. So we get 20,625, but I only want 3 total digits in my calculation. So our force would become 2,600 newtons. And that would be your force for this. Again, on the calculator, it read out it's 20,625. I only wanted 3 what we call significant digits, and so that would be your final answer. Okay, so I have shown you in this whole video here, I've shown you different ways to solve for each variable in the Newton's second law problem. What I need you to do is I need you to complete the problems 3 and 4, and then on the second page, I need you to complete all of these particular problems. Hope you have enjoyed this video, and as always, make sure you have subscribed.